This is video 2 for lesson 3 in Unit 5 of Chemistry 2. We have been looking at example problems to solve for uses of Kc. So how do we use these equilibrium problems to find out how much of product and reactant are going to be present when a system reaches equilibrium? So on number 3, it says, consider the same system at equilibrium as we had in our previous example on video 1. If we have 0.600 moles of A and 0.200 moles of B, and we mix them in a 2-liter container, and they are allowed to reach equilibrium, what are the equilibrium concentrations of all species? So our equation was A plus B is in equilibrium with C plus D. And our Kc value is given as 49.0. So that comes from our previous example. Now, in this case, A and B have different amounts to start with. We still have a 2-liter container, so we have to calculate the molarity of both A and B. So A is 0.600 moles over 2.00 liters, which gives us 0.300 molar. And B is 0.200 moles over 2.00 liters, which gives us 0.100 molar. So those are our initial concentrations. So before this reaction starts, we do not have any C or D. So we're going to need an ICE chart for this. So remember that ICE stands for initial, change, and equilibrium. So initially, we have 0.300 molar A and 0.100 molar B, and no C or D. We know that the only way that this reaction is going to go is to the right side. And that means, we could calculate Q and figure that out with C and D being on the top, and Q would be 0, so it has to shift this direction in order to proceed towards equilibrium. But with that, we know that these are both going to decrease by the same amount because their coefficients in front are 1, and these two, C and D, are going to increase. So at equilibrium, these are going to be the amounts of A, B, C, and D. So the Kc, which is 49.0, is equal to the concentration of C times the concentration of D over the concentration of A times the concentration of B. Each one raised to their stoichiometric coefficients. So when we substitute these values in, we get x times x all over 0.300 minus x times 0.100 minus x is equal to 49.0. Now we have a problem. We cannot take the square root of both sides of this to simplify this easily. So we have to go back into our algebra toolkit and think, what could we use to solve this? And there are a couple videos in our Schoology supplemental video folder that will help you figure this out. So if you pause this video and go to that folder and watch those videos, you can view that. So hopefully you went and viewed those videos and you realize that we are going to have to use the quadratic formula to solve this. So in order to use the quadratic formula, we have to solve this for 0, or we have to set this to 0. The second thing we do is we need to define A, B, and C, and then we have to use the quadratic formula to solve for x. So if you remember the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's do this. So we're going to set this equation equal to 0. So we are going to have to factor this a little bit. So we're going to have to simplify this, and x times x is x squared. And then we're going to have to FOIL the bottom. So when we FOIL the bottom, we get 0.0300 minus 0.400x plus x squared. And that's all equal to 49. So the next thing we do is get rid of the fraction. So I'm going to multiply both sides by this polynomial. So I'm going to get x squared is equal to 49.0 times 0.0300 minus 0.400x plus x squared. So I am keeping with 3 significant figures in all of these, so that can help a little bit. So when we do this, now we have to distribute the 49 to everything here. So 49 times 0.0300 is 1.47. 49 times negative 0.400x is minus 19.6x. And then 49 times x squared is plus 49.0x squared. Now, the last thing that I have to do to set this equal to 0 is subtract x squared from both sides. So I get 0 is equal to 1.47 minus 19.6x plus 48.0x squared. So now we are in standard form. It is set to 0, so it's ax squared. So this value right here, positive 48, is our a, plus bx, so negative 19.6 is our b value, plus c, 1.47 is our c value. So now that we have those values, we can plug that into the quadratic formula. So x is equal to negative b, so negative times negative 19.6 plus or minus the square root of b squared, so negative 19.6 quantity squared, minus 4 times a times c, all over 2 times a. So now we have to solve this mathematically. Whenever you do these for homework, for a graded worksheet or quiz, I need to see at least this step. So I need to see that you have this set up properly. The more work you show, the better. So I should be able to see this step here, your problem setup. I should be able to find this easily. And then I should be able to see the quadratic formula setup. I usually try to do this in pieces. So I know that a negative times a negative is going to be a positive. So we have this. And then I am going to put this in a calculator a very special way because we have to be very careful about order of operations, especially when we're taking this negative squared. So how I'm going to put this in a calculator, I'm going to put 4 times 48.0 times 1.47 and hit equals. That is going to store that as my answer. Since I know that this is a negative right here and we square it, a negative times a negative is going to be a positive. So I'm going to take 19.6 squared minus second answer. And that gives me 101.92. And then I'm going to take the square root of it. So second square root second answer equals. And that gives me 10.099 or 10.09554357. And again, since we are doing 3 significant figures, I'm going to round that to 10.1. That's all divided by 48 times 2, which is 96.0. So because we have this plus or minus here, we're going to get 2 answers. So in the calculator, if I put 19.6 plus 10.1, then divide that by 96, I get 0.309. Or 19.6 minus 10.1 divided by 96 gives me 0.0 990, rounded to 3 significant figures. So these are my two values. If you get a negative value, that's automatically thrown out because we're not going to have a negative change. Then we have to look. One of these we have to throw out. And if we go back up here and look, if we put x in for here and here, that's going to give us a negative molarity. So this value is too big. It won't work if we substitute this back in. So here is our x value. And now we're going to substitute that back into a. So a was 0.300, and then we're going to take minus 0.0990. And that gives me 0.201 molar for A. For B, when I substitute it in, I get 0.00100 molar. So I have very little of B left. And C and D are equal to one another, and it is just X. So that's how much C and D I have. So we have one more video example, and then you'll be able to work on the several worksheets that we have.